Back-to-back bends 4. For making back-to-back 90 degrees stubs, or U, bends, first determine the distance needed for the back-to-back bends as shown in figure 4:1. Determine the dimension for the BACKTO back bend. Bend the first stub as outlined in Chapter 3. To make the second bend, measure required distance between stubs from the back of the first stub that was bent, as shown in figure 4:2. Deduct take up and bend as shown. If the distance between the two stubs is quite long or if there is not enough pipe left after deducting take up to make the bend, reverse the bender and bend the second stub facing the opposite direction, as shown in figure 4:3. Bending the second stub in this manner requires only bending up the short end of the pipe, rather than bending and lifting the full length of pipe. Figure 4:3. Desired distance between stubs. Amount added for reversing bender. When you turn your back on the end of the pipe that you originally measured from, take up is not used. Instead, an amount must be added to the desired distance between the stubs for the back-to-back bends to come out right. Most benders have a mark that may be used when the bender has been reversed to bend back-to-back bends, while other benders have the amount that must be added printed on the bender head. If your bender has no marks or information printed on the bender head, you can bend a scrap piece of pipe to find the amount that must be added. To determine the amount that must be added for reversing the bender, bend an 8 inches stub in a scrap piece of pipe. Using the bender handle as a straight edge, measure over 24, and place a mark on the conduit, as shown in figure 4:4. Reverse the bender on the pipe, your back is now to the first stub you just bent. Place the arrow or other mark on the 24 inches mark and bend a 90 degrees stub. Measure the back FA back dimension of the two stubs measuring from outside to outside, as shown in figure 4:5. The outside to outside measurement between the stubs will be less than 24. The amount that the measurement is short of 24 is the amount that must be added to the desired measurement between the stubs for accurate back-to-back bends. The amount that must be added will vary with each pipe size and bender used. Tip: when bending stubs, if you must turn your back on the first stub to bend the second stub, you must add to the desired measurement, do not subtract take up. Kicks 5. The term kick is applied to any bend of less than 90 degrees. Its primary use is for direction changes, and works exceptionally well for entry into boxes and/or cabinets, as shown in figure 5:1. The degree of bend for a given amount of kick will depend on bender placement on the conduit. Bending close to the 90 degrees stub requires more angle of bend for a given kick height, while bending further away from the stub will require less angle of bend to achieve the same kick height, as shown between figure 5:2. Installation requirements will usually dictate where the conduit is to be kicked. If possible, use the smallest amount of angle to achieve the necessary kick that will make wire pulling easier. The easiest method of hand bending kicks after the initial stub has been bent is to place the conduit in the bender and level the stub horizontally, as shown in figure 5:3. Holding a rule next to the leveled stub, measure to the top of the conduit. Mentally add the amount of kick that is needed to this measurement and start bending until the stub reaches the required height on the tape, as shown in figure 5:4. Offset 6. OTF sets are used to change conduit elevation, to go over or under an obstium, or for entry into boxes, cabinets, etc. The offset is achieved by bending two bends of equal degrees. The first bend is made and then the conduit is rotated 1800 and then the second bend is made. Figure 6:1 shows an offset with two bends having the same degree of bend, A and B. Perfectly fitting offsets can be easily and quickly made if a few basic rules are understood and followed. The degree of bend is dictated by the space requirements. The smaller the angle of bend, the larger the space needed to complete the elevation change as illustrated in figure 6:2. If space is no problem, the angle of bend should be kept small to make wire pulling easier. Unlike the 900 stub that is measured overall, the offset is measured bottom to bottom. As shown in figure 6:3. Offset 6. OTF sets are used to change conduit elevation, to go over or under an obstium, or for entry into boxes, cabinets, etc. The offset is achieved by bending two bends of equal degrees. The first bend is made and then the conduit is rotated 1800 and then the second bend is made. Figure 6:1 shows an offset with two bends having the same degree of bend, A and B. Perfectly fitting offsets can be easily and quickly made if a few basic rules are understood and followed. The degree of bend is dictated by the space requirements. The smaller the angle of bend, the larger the space needed to complete the elevation change as illustrated in figure 6:2. If space is no problem, the angle of bend should be kept small to make wire pulling easier. Unlike the 900 stub that is measured overall, the offset is measured bottom to bottom, as shown in figure 6-3. Using the magic circle and covering the unknown value, we can find the hypotenuse by dividing the opposite side, 8, by the sine of 30 degrees. From the partial trig table shown, we find that the sine of 30 degrees is 0.500. H equals 0 divided by sine h equals 8 inches divided by 0.500 h equals 16. Place a mark on the conduit where you want the offset to start. From this mark measure over 16, and place a second mark on the conduit. Marks placed on the conduit for bending offsets should be drawn completely around the conduit. This will keep the mark from going out of sight when the pipe is rolled 180 degrees for the second bend. Put the conduit into the bender shoe and line the first mark up with the arrow, as shown in figure 6-6. Note: the arrow, the front hook of the bender, or any point on the bender can be placed on the bending marks for bending, but the same point or reference must be used for both the first and second bend. It is assumed, however, that most handbenders have an arrow or star, and all diagrams and descriptions in this book will use the arrow as a reference. Bend the first 30 degrees bend. Then roll the conduit 180 degrees, making sure to line the second bend up with the first bend to avoid misalignment of the two bends. Use an elevated platform or stairway, if available, to make the second bend, as shown in figure 6-7. Bend the second 30 degrees bend and a perfect 8 inches offset has been achieved. If an elevated platform or stairway is not available, invert the bender handle and place the handle on the floor to complete the bend as shown in figure 6-8. Use your foot to keep the inverted handle from slipping. Pull down with the hands, keeping one hand as close to the bender head as possible, holding the pipe down in the bending shoe as the pipe is bent, as shown in figure 6-9. Tip: if you are making several bends with the bender handle inverted and are having trouble with the handle slipping, buy a crutch tip at a local hardware store and install in on the end of the bender handle. This will give added traction, even on slick concrete floors. Another technique for bending with the bender handle inverted is to place the pipe under your armpit and use the weight of your body and your hands to form the pipe in the bender shoe, as shown in figure 6-10. This technique works well with 3/4 and EMT. Care must be taken when the bends are made if perfect results are to be expected. A few degrees too much will make the offset too high, and bending less than the required degrees will make the offset too low. As we have seen, the spacing between marks can be found using trig formulas. This is time-consuming though and is not necessary. A quicker, more practical method uses the cosecant of the offset angle. The cosecant is the ratio of the hypotenuse to the opposite side. The cosecant number can be used to determine the spacing between the offset bend marks. The cosecant by degrees is listed in the trig chart at the back of the book. A 10 degrees angle has a cosecant of 5.7588. This tells us that the length of the hypotenuse will be 5.7588 times the height of the opposite side, the obstruction. In other words, if we multiply the height of the obstruction by 5.7588, we can determine the length of the hypotenuse, which gives us the spacing between the offset bend marks. A 30 degrees angle has a cosecant of 2.000, or the hypotenuse is 2 times as long as the opposite side is tall. Multiplying the height of the obstruction by 2.000 would give us the spacing between the offset bend marks. The cosecant of any angle can be used to determine the spacing between the offset bend marks. Determine at what angle the offset is to be bent and simply multiply the cosecant of the offset angle times the height of the offset to find the spacing between the bends, which is the hypotenuse. When the cosecant of the angle is used in this manner, it is called the offset multiplier. To save time, Table 6-11 lists common angles used when bending offsets and their offset multipliers, cosecant, rounded to 3 digits. These values should be committed to memory. If not, cut and fold the trig table on the green card at the end of the book and carry it in your wallet. Offset multipliers. Table 6-11. Example. Lay out a 12 inches offset USMG 45 degrees bends. The offset multiplier, cosecant, for 45 degrees is 1.414 as shown in table 6-11. Multiply 1.414 times the height of the offset, which is 12. 1.414 by 12 inches equals 16.968, or just under 17. As we only expect accuracy to within, we will round up and make the spacing between the bend marks for our 12 inches offset at 17, as shown in figure 6-12. When converting decimal numbers to fractions when bending offsets, always round the number up to the nearest, is. As conduit is usually marked with a wide pencil or felt tip marker, the marks themselves are almost, wide. There is no need to try and measure to within a 1/16 or 1/32 of an inch. By rounding up to the next closest, the offsets will always be tall enough to clear the obstruction. With offsets it is better to be a bit high than to come up short and not clear the obstruction. While the pipe can be bent again to gain the necessary clearance, it will require extra work, which wastes time. Math tip. To convert your calculator answer to the closest, multiply the fractional numbers by 8. If the answer is 16.968, as in the previous example, multiply the fractional portion 0.968 times 8. Your answer will be 7.744. This means that there are 7.744 Round the 7.744 up to 8 and we get 8 eighths, or a whole number value of 1. 1 is then added to the 16 inches to get a measurement between the bend marks of 17. If the answer you are trying to round is 14.334, multiply the 0.334 times 8 for a value of 2.672. 2.672 eighths rounded up will be 3 eighths. The is added to the 14 inches, making the spacing between the bend marks 14 and 3 eighths. The method for determining the spacing between bend marks for bending offsets, as shown in tables 6 to 11, will work for any size conduit, using any type of bender, hand, Chicago, style, electric, or hydraulic. Tip. For conduit that will be painted after installation, do not use a permanent ink marker, as the marker ink will bleed through the paint. What angle of offset is the most common when hand bending EMT? It depends on the individual and the tools available. Some EMT benders are designed so that when a 45 degrees bend has been achieved, the bender handle will be vertical. Other benders have a built-in level vial to indicate 45 degrees, figure 6 to 13, while other benders have raised lines cast into the bender head that WHCN lined up indicate various degrees of bend. Other benders are designed so that a 30 degrees bend has been achieved when the handle is vertical, plumb, and the line for 30 degrees is parallel with the work surface, as shown in figure 6 to 14. Note that other angles 10 degrees, 22 degrees, 45 degrees, and 60 degrees can be determined when the line for each degree is parallel with the work surface. 30 degrees offsets are popular with electricians because the offset multiplier is 2.0. An offset multiplier of 2 simplifies the math necessary, as we can usually figure offset spacing using a multiplier of 2 in our head. For finding other angles, use a protractor level with a magnetic base like the one shown in figure 6 to 15. Problems. Determine the spacing between the bend marks for a 22 inches offset using A. 45 degrees bends, B. 30 degrees bends, C. 15 degrees bends. Box offsets. Box offsets are the most used offset application. It is not practicable, however, to mark and lay out normal box offsets in smaller sized EMT. These offsets are achieved only by practice and for this reason will not be covered. For accurate box offsets in larger conduit sizes, normal offset procedures are required. When bending offsets for buried work or for installations where the finished offset will be covered, an alternate, but less accurate, method of bending offsets may be used. This alternate method does not use offset multipliers as previously discussed, but rather uses a measurement for offset height after the first bend has been made. Example. To bend a 6 inches offset using the alternate method, proceed as follows. 1. After the first bend of the offset has been made, lay the bender handle next to the pipe, as shown in figure 6 to 16. 2. Using your tape measure at 90 degrees from the end of the bender handle, measure out 6 inches and mark the pipe for the second bend of the offset. 3. Put the pipe back in the bender, align the pipe and bend the second bend of the offset. The results will be an offsets of approximately 6 inches. Tip. For offsets in larger sized EMT that cannot be bent using hand benders, usually I and above, or when a bender is not available, factory sweeps or factory bent 90 degrees pipes can be cut in half, rotated and coupled together to form an offset. Greater offset depth can be obtained by adding a short piece of conduit of the required length, as shown in figure 6 to 17. Predetermining offset location. 7. The hardest part about bending an offset is properly aligning the pipe in the bender to avoid any misalignment between the two offset bends. The misalignment of the bends is called a dog leg, or in some parts of the country it is called a wow. As with any skill, proficiency comes with experience. Once proficiency has been achieved, the next step is to learn how to locate the marks on the pipe so the location of the offset can be determined prior to bending. By knowing that the offset will be in the right location after the offset is bent will save time and avoid having to cut the pipe to fit, or having to add extra pipe and a coupling to make it fit. Predetermining offset locations is an easy procedure requiring little additional time, but will pay large dividends in material and labor units saved. Two methods for predetermining offset location will be discussed. Study both methods, then use the one that you find easiest to apply for a given set of circumstances. Predetermining offset location method number 1. The key to this method is establishing constants for the different pipe sizes and angle of offset bends. This method can be used for any angle offsets and any pipe size. Figure 7:1 shows an offset that is to be bent with two 45 degrees bends. Notice that both the opposite and adjacent side of the right triangle are 6 inches, or are equal, or have a ratio of 1:1. If the pipe was bent like the drawing, to locate the center of bend A, we would need to subtract 6 inches, the length of the adjacent side from 24, the distance from the box to the obstruction to get a value of 18. This value, 18, is the distance from the end of the conduit to bend mark A, the first bend of the offset. As shown in figure 7:1, of course, in reality conduit is bent to the radius of the bending shoe, as shown in figure 7:2, not at right angles, as shown in figure 7:1. Notice that for a short distance before the right triangle formed at bend A, and after bend B, the conduit is not straight. This is caused by the radius of the bend. For the offset to fit properly over the obstruction, the offset must be shifted to the left, toward the box, so the pipe is straight and no part of the bend is touching the obstruction. We need to locate the bend marks so that when the offset is completed there is straight pipe at the edge of the obstruction. To accomplish this, an amount is added to the height of obstruction, opposite side, measurement before subtracting the value from the distance from the box to the obstruction. The amount that must be added for 45 degrees offsets can be found as follows. 1. Bend a 45 degrees bend in a scrap piece of pipe. 2. Remove the pipe from the bender, locate and mark the center of the 45 degrees bend. 3. Using the bender handle as a straight edge, measure from the center of the bend to a point where the conduit is straight on the bender handle measurement D, as shown in figure 7:3. As there are two bends in each offset, the measurement, D, is doubled, and this amount must be added to the height of the obstruction, H, the total of the two measurements, 2D plus H, is then subtracted from the distance from the box to the edge of the obstruction to locate bend mark A. This adjustment compensates for bending on a radius and assures the pipe will be straight when it passes over the obstruction. The amount that must be added is called an offset constant and will be different for each pipe size and angle of offset. Table 7-4 lists offset constants that have been established for 1/2, 3/4, and 1 inch EMT to compensate for the radius of both bends of a 45 degrees offset. For 45 degrees offsets, the height of the obstruction, opposite side, is equal to the adjacent side, giving a ratio of 1:1. With this fact in mind we can add the 5 inches offset constant for Y, EMT to the height of the obstruction and subtract the combined measurement from the distance from the box to the obstruction to locate bend mark A. Note: for simplicity, examples and problems will be drawn in one-line form, and box offsets will not be included. Example: a 45 degrees offset is to be bent using 1/2 EMT to clear a 6 inches I beam that is located 28 from a box, as shown in figure 7-5. Using method number 1, locate bend marks A and B. Height of obstruction, H, 6 inches. Offset constant for Y 1/2 EMT plus 5. Total 11. Distance from box to obstruction 28. Subtract H plus offset constant 11 inches. Total 17. Measure 17 from the end of the conduit and mark bend mark A as shown in figure 7-6. Multiply 1.414, offset multiplier for 45 degrees offsets, times 6 inches, height of the obstruction, to find the spacing between bend mark A and bend mark B. 1.414 x 6 equals 8.484, or 8.5. This is the spacing from bend mark A to bend mark B, as shown in figure 7-6. Note: see the decimal to fraction conversion table in back of book if you need help converting decimal numbers to their fractional equivalent. You can also find the fractional equivalent using your calculator. Multiply the value after the decimal times 8 to 10 the equivalent in eighths. In the previous example the value was 8.484. Multiplying 0.484, the value after the decimal, times 8 give us 3.872 eighths. Rounding up to the next eighth would be 4/8 or ease. Example: Bend a 12 inches offset using 45 degrees bends with I. EMT as indicated in figure 7-7. Locate bend marks A and B. 1. Add the 12 inches height of obstruction to the 3/4 EMT offset constant of 6 1/4, for a total of 18 1/4. 2. Subtract 18 1/4 from the 48 inches distance from the box to the obstruction for a value of 29 3/4. 3. From the end of the pipe measure 29 3/4, and mark bend A4. Multiply the height of the obstruction by I.414 to find the spacing between bend marks A and B, as shown in figure 7-8. 12 inches by 1.414 equals 16.968 or approximately 17. Figure 7-8. Problems. Layout bend marks A and B for the following offset projects. All offsets are 45 degrees, the EMT pipe size are as listed. To preposition offsets for other than 45 degrees we will use offset location multipliers. These multipliers will be used only for locating the first bend mark of the offset, bend mark A, and must not be confused with offset multipliers that are used to find the spacing between bend marks A and B. For 45 degrees offsets we found that the height of the obstruction, opposite side, was equal to the adjacent side, or we could say the ratio of the opposite to the adjacent was 1:1. For any other degree of offset angle the ratio will be different. Example. Offsets bent using 30 degrees bends will have a ratio of 1:1.73 between the opposite, height of obstruction, and adjacent side. The added length of the adjacent side can be seen in figure 7-9. We can prove the ratio using the formula shown in figure 7-10. Look up the tangent of 30 degrees using the partial trig table in figure 7-11. By dividing the opposite side by the tangent of 30 degrees we can determine the length of the adjacent side. Adjacent side equals 0 divided by t. Adjacent side equals 8 divided by 5.774. Adjacent side equals 13.86 or tilde 13 7/8. To find the ratio of the opposite to the adjacent side for 30 degrees offsets we divide the adjacent side by the opposite side. Ratio equals adjacent side, opposite side. Ratio is equals 1.73. This tells us that for an offset bent with 30 degrees bends, the adjacent side will always be 1.73 times longer than the height of the obstruction. Opposite side. The ratio of 1:1.73 will be true no matter what size pipe is used and no matter what the height of the obstruction is. If the ratio is always true, the height of the obstruction can be multiplied by 1.73 to find the length of the adjacent side for predetermining offset location using method number 1. Stated another way, the 1.73 becomes an offset location multiplier for 30 degrees offsets. The offset constant, as shown in table 7-5, to compensate for bending on a radius and to assure straight pipe where the pipe crosses over the obstruction change as the angle of offset bends change. Table 7-12 lists the constants for 45 degrees, 30 degrees, 22½ degrees, and 10 offsets using 1/2, 3/4, and 1 inch EMT. Table 7-12. Note. For other offset angles use the procedure discussed earlier and, as shown in figure 7-3. Example. Locate bend marks A and B to preposition a 10 inches offset with 1/2 EMT using 30 degrees bends, as shown in figure 7-13. 1. Multiply the height of the obstruction, 10, times the offset location multiplier for 30 degrees offsets, 1.73. 10 times 1.73 equals 17.3 or equals 17/3/8. 2. Add the offset constant for 300 bends to compensate for bending on a radius as found in table 7-12, 4.5, to the adjacent side, 17 3/8, to find the amount that is subtracted from the box to the obstruction measurement of 42 inches to locate bend mark A 4.5, plus 17 3/4 equals 21 7/8. 42 inches minus 21 7/8 equals 20 1/8. Measure 20 1/8 from the end of the conduit and mark bend mark A, as shown in figure 7-14. 2. The distance between bend mark A and B is found by multiplying the height of the obstruction, 10, by the offset multiplier for 30 degrees, which is 2.0. 10 inches by 2.0 equals 20. Measure 20, from bend mark A and mark bend mark B, as shown in figure 7-15. Table 7-16 gives the offset location multiplier for predetermining offset location using method number 1 for 45 degrees, 30 degrees, 22½ degrees, and 10 degrees offsets. Note. The offset location multiplier for other offset angles can be found by looking up the cotangent of the angle in the trig table at the end of the book. Example. Locate bend marks A and B for a 6 inches offset using 22.5 degrees bends and 3/4 EMT, as shown in figures 7 to 17. 1. Height of obstruction multiplied by the offset location multiplier for 22.5 degrees offsets using 3/4. Pipe is found in table 7 to 16. 6 inches by 2.42 equals 14.52 or tilde 14 1/2. 2. Add the offset constant for 22.5 degrees offsets for 3/4 EMT, as shown in table 7 to 12. 14.5 plus 4 1/4 equals 18 3/4. 3. Subtract the 18 3/4 from the distance from the box to the obstruction to locate bend mark A, as shown in figures 7 to 18. 58 inches 18 3/4 equals 39 1/4. Measure 39 1/4 from end of pipe and mark A. 4. Multiply the height of the obstruction, 6 inches, by the offset multiplier for 22.5 offsets as found in table 6 to 11, 2.613, to find the spacing between marks A and B. 6 by 2.613 equals 15.678. As this measurement will determine the height of the finished offset, we will round 0.678 up to the next, to 15 3/4, as shown in figure 7 to 17. Predetermining offset location method number 2. This method for predetermining offset location requires the use of shrink values. Shrink is the amount the overall length of a pipe will shorten, or shrink, when the offset is bent. To determine shrink for a given offset angle, proceed as follows. 1. Measure the overall length of a scrap piece of pipe. The scrap piece of pipe in figure 7 to 19 has an overall length of 36. 2. Calculate spacing between bend marks A and B for an 8 inches offset using 30 degrees bends. 8 inches by 2 equals 16. 3. Bend the offset and then measure the distance from one end of the conduit to the other, as shown in figure 7 to 20. 4. Subtract the new length of 34 from the original overall length of 36 inches to find a total shrink of 2. 36 inches 34 inches equals 2 of shrink. 5. Divide the total shrink of 2 inches by the height of the obstruction, 8 inches, to find the shrink per inch of offset, or shrink per inch of rise. 2 inches divided by 8 inches equals 0.25 or 1/4 of shrink per inch of rise. Example. Find the total shrink for a 14 inches offset using 30 degrees bends. 14 inches by 1/4 equals 14/4 or 3 1/2 of total shrink. Once the shrink value has been found for a given offset angle, the value will apply to any size conduit, EMT or rigid. Table 7 to 21 shows shrink values for the most common offset angles. Note. To find the shrink values for other angles of bend, locate the cotangent for the offset angle in the trig table and subtract the value from the cosecant of the same angle. Convert the decimal answer to fractions of an inch to obtain shrink per inch of rise. These are purely mathematical values, and while they will be very close, for the most accurate shrink values, always bend a scrap piece of pipe to determine shrink per inch of rise for the bender you are using. Figure 7 to 22 shows an offset consisting of the 30 degrees bends and a 10 inches obstruction, or 10 inches of rise. By using the shrink value for 30 degrees, 1/4, you need only multiply this value by the height of I0, to get total shrink. 10 inches by 1/4 equals 10/4 or 2 1/2 of total shrink. If the pipe is 60 inches long, it will shorten, or shrink, 2 1/2 to 57 1/2, overall, after the two 30 degrees bends are made. Likewise, a mark placed on the conduit will end up 2 1/2, closer to the box once the pipe is bent. By knowing how much the mark will move allows us to mark the conduit and predetermine the offset location. By measuring the distance from the box to the front of the obstruction, as shown in figure 7 to 23, which is 40 inches, and adding to this measurement the shrink value for a 10 inches offset using 30 degrees bends of 2 1/2, we get a measurement of 42 1/2. We can place a mark on the pipe 42 1/2 from the end of the conduit, and this mark will end up at the front edge of the obstruction after the offset has been bent, as shown in figures 7 to 23 and 7 to 24. After the offset is bent, the pipe shrink will move the mark 2 1/2 toward the box and the mark ends up at the edge of the obstruction. By using this mark, distance plus shrink, as bend mark, we can pre-position the bend marks so the finished offset will fit perfectly from the box to the obstruction. The actual bending will require that we turn our back on the end of the conduit we measured from. This will put the bend itself to the left of bend mark A and leave straight pipe to cross over the obstruction, as shown in figure 7 to 25. Bend at bend mark A first and then bend at mark B. The bend marks are reversed on the pipe as a reminder that you must turn your back to the end you measured from, or think of turning your back on bend mark B.